Okay, here we go. Number 5. Figure above shows the graph of f prime. Take your time on that one. This is the derivative of a twice differentiable function f. The interval is -3 to 4. The graph of f prime has horizontal tangents at x equal -1. That seems pretty clear. X equal 1, x equals 3. So I've read 2 sentences now, and I feel very comfortable with what they're giving me. This is f prime, got horizontal tangents. The areas of the regions bounded by the x-axis and the graph of f prime on the interval -2 to 1. So from here all the way to here, this area is equal to 9 and 12 respectively. So this is 9, and then this area here from 1 to 4 is 12. And then I have a comma, so I stop and a period. Good. So I feel comfortable with that. I'm done with the reading. Any questions about the reading? Keep going. Find all x coordinates. So probably circle x. Find all x coordinates where f has, read carefully here, relative max. Go slow. Don't lose a point because you read relative min. Give a reason. So that's straightforward. It's right here on the golden notes. So right here, front page, we're looking for a relative max. Good. Matches the golden notes perfectly. So f has a relative max or local max when f prime changes positives negative. And I even have examples on the back here to help you remember how to do that. So here we go. Local min, or in this case would be relative max. At x equal 3, f prime changes negative to positive. Not an example. I know exactly what to do. Come back to the front. And got distracted. So give me just 1 second to build this picture. Give me 1 second. Let's pause this for. Okay, hey, look out. So 2 points on part A. The only spot where f prime changes from positive to negative is right here at x equals -2.
Parallel.
So if you have this box, no one talked to me. If you have this box written on your paper, this is 2 points. If you're unsure as to whether you got maybe half credit, just ask me. But that's 2 points right there. Anybody else? Awesome. Next one. Part B. Part B says on what open intervals, they give you a hint right there. Plus my advice is, unless you're just positive, you're safest to just use open intervals. On what open intervals from -3 to 4 is the graph of f both concave down and decreasing? So that's a Danish chart problem. So I need to think, okay, f needs to be decreasing and f needs to be concave down. So that means I'm looking for f prime is negative, and simultaneously f prime is decreasing. I'm looking there. So here f prime is decreasing, not negative. So here we go. Here's f prime decreasing, and f prime is also negative. Happens again here. So I would write on my paper for the intervals, open interval -2 to -1, and interval 1 to 3, decreasing and negative. So F is both see when F prime is decreasing, F is concave down. You don't need an E on both, but if you do that, they won't take a point off. So the Gothic German way of spelling both or something, I don't know. That's a bad joke. F prime is both, so F is both concave down and decreasing on those intervals. And that's 2 points for that. You have what's written in blue? No one talking, Ken, here.
I was just wondering if you would have put T equals -2, would still be negative.
I think if you did, I got you.
almost did.
Yeah, I think if you accidentally put T equal, they won't deduct the point for that. I think you're in that one.
Okay, so when I wrote the interval solution,
No one talking, Ken, here.
instead of writing in parentheses -2 comma -1, I wrote -2 less than or equal to x less than or equal to.
Totally fine.
Okay.
Yeah, those are perfectly equivalent. There's no difference.
One question is, first of all, so I said final x is equal to 0 when the f is decreasing, and then double bond x is equal to 0 when it's concave down. And I said that occurs on between -2 and -1 and 1 with the.
They would get that. That was fine.
But then I didn't say -2 less than equal to x was equal to -1. I said -2 less than x.
Yeah, that's what you're supposed to do, because it's supposed to be open interval anyway. So open means not equal.
So less than.
Just less than, not less than, which is what you said. So.
Yeah.
Yeah, that's okay. Please.
What if for the interval I wrote from x equals -2 to x equals -1, and from x equals 1 to x equals 3?
You do stand a possibility of only getting one of 2 points because they specifically mentioned that you needed to have an open interval, and because you used the equal sign, you were defining a closed interval. So it's a bit borderline. They might be lenient, I'm just not sure. So for practice test, I would go with 1 out of 2 to keep pushing yourself to get a little bit better. Hannah, please.
Earlier you were saying that brackets and parentheses didn't matter, like whichever one you wrote, but in this case it doesn't matter because I wrote brackets.
Oh, I gotcha. Back up. Sorry. Let me see if I remember what I said, because I want to make sure that you understand the difference. We were looking at a problem here. It was Maddie's question, right? I think so. So 1 second. So what we were looking at was number 3, and it was a case like this. Is that right? Gotcha. So in this situation where you're just using parentheses or brackets to kind of indicate that it's a grouping symbol, it doesn't matter. They mean exactly the same thing. That's perfect. However, when you're using brackets or parentheses to indicate an interval, now it's different. The brackets mean closed interval and the parentheses mean open interval. So the brackets mean, less than and equal to. The parentheses means just less than. So those are different. So when you're defining intervals, I always use open unless I'm just really compelled to use a close. It's just safer. Most always you'll get credit for sure if you have the open interval on intervals. Did that answer your question?
Yeah, so right?
So it's a bit borderline. I think I'd give myself 1 of 2. I think they'll dock you 1. Like your reasoning is right, but you use closed instead of open. I think they'll give you 1 of 2. Does that make sense?
Yeah, I didn't do.
So you didn't have the reason either.
Yeah.
Okay. So you wouldn't give me on that one. Even.
How, would you tell the difference, this is probably a dumb question, of an interval and a point? Doesn't that just look like?
Yes, it's very good. It's like a lot of things in the English language, it's context sensitive. Yeah, because it looks just like a point. It's just the fact of what we're talking about. They ask for intervals, so now they know you're talking about intervals. Good question. It's a very good question. Please, Matt.
So my question when I was doing this, I did the parentheses, but then I was thinking that if it was the n that was just -3 or 4, then it would be bracket and in parentheses. Is that correct in your rule?
when you're talking about concavity, the strict mathematical definition of concavity is always going to be an open interval. For increasing or decreasing, they actually will accept either one. So that's why I just say, hey, if we just always do open, it's easier to remember, and you don't have to worry about it. Is that your question? Two pebbles as well? Anybody else? Two pebbles for every question, even if I don't say it. So, okay, next one. C says, hey, find the x-coordinates of all points of inflection. So x-coordinates, points of inflection for the graph of f, period. Give a reason. One other reminder here on the golden notes. Look, I personally find it a little difficult to remember all the different ways they expect me to justify my work. So that's why on the back of the golden notes I added, this is all brand new just for this year, I added all of these example statements just to give you something to look back on and remember problems you've done. Like the one we just did is very much like this. F prime is negative and decreasing on this interval. So f is both decreasing and concave down on that interval. That's an example of what we just did.
Okay, so on the AP test, can you use little abbreviations like C instead of decreasing and C for concave down?
Yeah, I've actually double checked that several times with graders that have actually graded the AP test.
And also plus and negative.
You can. I think the pause and like the POS and NEG is a little clearer. So that's what I prefer to use most of the time. But on the golden, yeah, so you're okay with those. Anybody else? Awesome. Back to here now. Point of inflection. F has a point of inflection. It's right here on the golden notes again. So front page. So there's two places you can look. You can look here. Here's an example. F prime changing, increasing to decreasing causes F to have a point of inflection. And it's actually either way. F prime could change decreasing to increasing. So either way is going to cause a point of inflection. I just need to write that on my paper now. So, let's see. Point of inflection. So I would write at x equal -1, F prime changes, and I can abbreviate, decreasing to increasing, at x equal +1, F prime changes, increasing to decreasing, and finally at x equal 3, F prime changes, decreasing to increasing. So F has inflection points. Here's one, Michael. I've never seen them say you can use IP for inflection points. So I always spell that one out. So F has inflection points, bad handwriting, at x equal -1, 1, 3. And I would get 2 points for that. Please, Abby.
So I did the F prime changing, increasing, decreasing, or decreasing, increasing, and then I got those points.
That would be okay.
That's okay.
Uh-huh. Yeah, you would. I just kind of, what I ended up doing is I just kind of read the graph and wrote as I read. Yeah, if you said something like, I'll read it back to you. At x equal -1, 1, and 3, F prime changes decreasing to increasing or increasing to decreasing. Therefore, F has inflection points. That would be fine.
What if I said instead of F prime changes to decreasing and increasing, I just said that I was another question when F double prime goes from positive to negative or negative to positive.
I think they'll leave it out. Be careful with one thing though. Just because f prime is equal to 0 doesn't guarantee that f double prime is going to change sign.
Well, I did say that it went from positive.
No, that's what I meant. So I think yours is fine. I'm just saying be careful with future matter. You're good. Let me explain. Yeah, that one's fine. The one thing you want to be a little careful with is they specifically said point of inflection. So what you said is, well, changing concavity means point of inflection, but that's part of what they're testing you on. So I think you'd be okay, but probably better to say point of inflection. Are you out? Oh, please.
You said, as you have point of inflection when f prime has a horizontal tangent and changes from decreasing to increasing or increasing, listed occur that I
I think they give you both points on that. Be cautious though. It's what I was saying to Brandon, sorry. F prime doesn't have to have a horizontal tangent for this to occur.
Okay, but it will have it if it does occur, so like it has to be increasing and decreasing, but does it always have a horizontal?
The example would be F prime can do this. And there's no horizontal tangent, but F prime is changing, decreasing to increasing, which means F does have a point of inflection. That's what I was cautioning you about. Does that make sense? Cool. There you go. Next one, part D. So they tell us that f of 1 is 3. Write an expression for f using an integral. We're supposed to find any value of f of x. Here we go, part D. Find a value of f of x. Well, it's the fundamental theorem. If I integrate from time 1, where I know the value of f, to some unknown time, and I integrate f prime. But right now, right at this moment, I remember that I'm not supposed to have variables matching here. So this is where they can just switch it to t, or z, or q, or u, or w, or anything you want. This would be dt. Per the fundamental theorem, this integral is exactly the same thing as how much f changes between these two values. So I write f of x, subtract f of 1. I'm going to do one more thing, but pause for questions here. Please, Mark.
Why does the, like, t and x, why do they have to be different?
Different. Let me say it back to you, and if it doesn't work, keep talking. When you compute this integral on a calculator, what happens is you plug in the 1, then you plug in 1.1, 1.2, 1.3, 1.4, 1.5, whatever, until you get to this value. So they have very different meanings. This is like a specific number, like 10. This is every number between 1 and 10. So we don't want them to have the same symbol because they have different meanings. Did that help? Yeah. Good. Couple. Anybody else? So rearrange this to get your point. You'd write f of x equals, let's see, f of 1 is 3, plus the integral from 1 to x of f prime. Question? That's worth 2 points for that. That is 2 points. Please.
Can you leave it as 1?
Absolutely. So f of 1 is fine. Jason?
If you didn't change the variables from x to t, are you going to lose 1 point?
So does it say x and x? That one's borderline. Mrs. Summers asked a person who actually graded the test, and what she said was, yeah, if we look at the work and everything else looks perfect, we'll probably let it go and be okay. Safer to not. So, anybody else? Okay. Then it says, find f of 4 and f of -2. Okay, all eyes on the board. This is a great example of why I say repeatedly, don't let yourself get stuck. You're just thinking, you've got to find something else to do. And it's also a great example of just one little thing at a time. The bulk of the points in this part D come from really very quick things. They're going to give me one more point if I do some more work. So get the easy stuff done first. The next step isn't too bad. If I want to find f of 4, I just use my formula. This also reflects back on your question, Lauren. I'm going to plug in f of 4, right? I don't want to put a 4 here. That's why the variables are different. So I write f of 4 equals 3 plus 1, 2, 4 of f prime. Oh, they didn't make it too bad because the integral from, now I messed up, I put x instead of half it. Once you put the number, you actually can write x, it doesn't matter anymore. dt. Okay, so look up here, I'm integrating f prime from 1 to 4. That area is 12, but it's below the axis, so it gets counted negatively. So this is going to equal 3 plus negative 12. I would just stop right there. That's the value for f of 4. That's good enough. You don't have to, I mean, you can. It doesn't hurt anything to write that that equals negative 9, but questions there? Oh, please, Joe.
Like, just the, like, explain to me what happens going, like, just the red part.
Okay. So are you okay that the first part of the red is simply using the formula?
Yeah.
The second part is I've got to find the value of this integral. So back to Brenda's question, nothing in the notation or the wording says that I'm supposed to be taking the derivative of this, so I don't. I need to find that integral's value. So back on the golden nodes, I have a reminder right here, front, side, middle. To find the value of an integral, one method is using arrows. Very good. Key things to know. We're integrating f prime. It's the graph of f prime. So one method of finding the integral of f prime is to say I've got to go from 1 to 4. So here's f prime, 1 to 4. And this area will correspond perfectly to this integral's value, except that because it's below the axis, you have to count it as a negative. Anybody else? Let's do one more. So it says f of negative 2. So I write f of negative 2 is equal to 3 plus the integral. Everybody watch this one. This one has a small twist. You don't want to mess up on the little twist here. That integral's backwards, so I'm going to change that using a property of integration. If I multiply the integral by negative 1 and reverse the limits, the integral is the same value. It's like it's perfectly equivalent. So I've not violated equality by doing that. Question? I need to integrate from negative 2 to 1. So here we are, negative 2 to 1. It's all under the axis again, so it counts negatively. So this is going to equal 3 plus negative 1 times, the integral gets counted as a negative. So now these, you can just leave it like that, just stop. If you kept going, you get 12. Please, Madam.
I didn't with the.
That's okay. If you, let me just say something back to Elma. Everybody watch. Hey, if you don't flip the limits and then multiply by negative 1, it's still fine. But you have to notice that because you're integrating going this way, here's the little symbol I use. I'm integrating this direction, above counts negative, below counts positive. I'm integrating this way, it's above is positive, that's negative. Just look. Yeah, they would, they can't tell. Yeah, they can't tell where you're making a mistake. So they wouldn't give you points because it's only worth 1. If you had to get both of them to get the point, but if it had been by itself, you would have actually put it down. Please,
Where did you get the negative 9 from?
okay, so one more time, Dave. So the way I did it, I used the formula, filled it out, and then I looked and said, hey, this integral is going right to left, backwards. So So I'd rather not do an integral going that way. So I'm going to change the limit so the integral goes this way. But you can't violate equality ever in mathematics. So to maintain equality, I have to multiply by -1. That's the rule. You switch the limits, you want to maintain equality, you have to multiply by -1. You with me? This integral now, ignore that negative, ignore the negative. I'm integrating from -2 to 1. -2 to 1. That means I'm paying attention to this area because I'm going that direction and this area is below the axis. That area gets counted as a negative. They told me the area was 9, but I have to count it negatively in terms of computing the integral.
If you would have just put 3 plus 9 there instead of maybe 109, would they still give that to you?
They would give it to you. They'd assume that you understood everything. Yeah. Anybody else? Cool. Next one. So that's the end of 5. Any other questions on 5? Going to 6 now.